Hi, Dr. Anthony Revis here with Watch Me Do It. In this one, I'm going to do empirical formula. So you get to watch me do an empirical formula. And here we go. Here's the problem. A compound is determined to have 1.71 grams of carbon and 0.287 grams of hydrogen. What is the empirical formula? This is probably done by combustion analysis, but the way it was analyzed doesn't matter. We have the final solution. Okay, so we have 1.7 grams of carbon and 0.287 grams of hydrogen. And we're assuming that this only has carbon and hydrogen in its composition. So let's do it. In order to do any empirical formula, as soon as you see the term empirical formula, you think moles. You think, I need moles. That's it. That's how we think about it. All right, so you need moles as soon as you see that. So let's just go get the moles. If we have grams, we can get the moles, right? Yeah, dimensional analysis, 1.7 grams of carbon. So we can get the moles this way. We go grams of carbon because we have grams here. Got to put grams there. Moles of carbon. So the grams per mole of carbon is 12.00 grams per every 1 mole of carbon. And we punch this this particular number 2 through, excuse me, and we get this number of moles of carbon. So that's how much carbon we have in terms of moles. And we must do the same thing for hydrogen. So we have 0.287 grams of H times bar, grams goes on the bottom, mole, H on top. And this will give us 0.284 mole of H. Now, an empirical formula is simply a ratio of its moles. So let's do the ratio to moles. So to do any ratio, you know how to do it. You'll take the smallest, take and use it on the bottom, divide by the smallest value. You punch this through to the nearest whole number. You get a 1 here and a 2 here. Therefore, the empirical formula is C1, H2, and we don't write the 1, so we call it CH2. That's my final square and answer. Let's do another empirical formula. A compound is determined to have 5.31 grams of chlorine and 8.70 grams of oxygen. What's the empirical formula? Again, assuming these are the only elements in the compound. Then we'll do the same thing. We will see the word empirical formula. We right away, I'm thinking mole. That's what I need. So let me get these over to moles. So I have 5 point to do that. I have 5.31 grams given. That's my given. So my given times bar, gram on the bottom, chlorine here, and mole on the top, chlorine here. And so I looked this up on a periodic table, and I get 35.28 grams every mole. This is basically a molar mass. So we have a molar mass here. And so that's going to be the molar mass there. We punch that number through on our trusty calculator. Don't forget to punch it the right way. You get the moles of chlorine for that. And now I'll do the same thing here for oxygen, or similar thing for oxygen. Same process, of course. Times bar, grams, O on the bottom to moles, O on the top. And this is 16.00, or very close to that for every 1 mole. I punch this through. I let my calculator do the work. And I'm going to get that number of moles of O. So next, because it's empirical formula, that means a ratio of moles. This means ratio of moles. That's all empirical formula wants to know. Okay. And so I divide by the smallest one. Divide by the smallest one here. Punch these numbers through. This one gets really easy. That's a 1 there. And this number comes out to an odd number of 3.5. Now, when we write empirical formulas, we don't write these with fraction numbers. Okay. So when it comes out to something like this, we've got to do something to get the one as a fraction, a whole number. So we have to multiply this times 2. Therefore, we have to multiply this times 2. So this becomes a 2. This is just math rules. This is the rules of math. So check your math rules. You'll get this. And this becomes a 2 and a 7. So the empirical formula here is Cl with a 2 and O with a 7. Again, I don't write it as 1 to O 3.5. We don't do it that way. We multiply everything times 2 to get it to whole numbers. So it's 2 to 7, a 2 to 7 ratio. And this is my square n final answer. And that's how we do the empirical formulas. That's how we do it.